Chapter 1, The Science of Nutrition, Screencast 1. I want to start off with this first slide and the definition that our textbook provides of nutrition. Now, as you read this definition, I want you to think about the complexity and the intricacies associated with nutrition. I think this is really important. When I took my nutrition courses in graduate school, it basically was applied biochemistry. So I want you to think about the importance and what's really implied here by this particular definition. We are looking at nutrition as an actual science. We're also going to be taking into account the nutrients themselves and what actually makes up those nutrients. What are the building blocks associated? Other things that we will be looking at is how do they interact and their impact on our lives and the potential for preventing or playing a role in creating various diseases. We'll also be looking at the actual processes that are involved in digestion. So one of the things I want you to appreciate is the complexity of nutrition. That's probably the most important thing that I want you to keep in mind as you start this course. Now, one thing that you'll also find out about me is that I am very interested in public health issues. And what this particular slide is showing, what are the leading causes of death in the United States? Now, what has been added to this, which of those particular leading causes have a nutritional component or diet actually plays a part? So if we look at the biggies, so heart diseases, cancer, stroke, if we look at diabetes, Alzheimer's disease, kidney disease, that's a lot of diseases that have some link to nutrition and the impact that our diet has on the leading causes of death in the United States. In addition to this, I want you to think about 4 behaviors in particular. And these behaviors really play a significant role in our risk for lifestyle-related disorders, such as diabetes, heart disease, and so on. And if I look at the behaviors, 1, whether or not you exercise. 2, do you smoke? 3, how much do you drink alcohol? And 4, last but not least, nutrition itself. Think about that. Those 4 behaviors account for contributing in some way the majority of those diseases that are killing Americans. Think about that. That's powerful. Now, since we're talking about nutrition, we have to focus on nutrients. And a nutrient is defined as those things that are essential for health that the body cannot make or makes in quantities too small to support life. We're going to further distinguish this definition into essential nutrients. So in addition to that definition of a nutrient itself, what we're going to look at here is these nutrients that are essential have a specific biological function. If you're not getting these nutrients in your diet, they're going to result in some observable decline in biological function. And the last characteristic is when you put those back into your diet prior to permanent damage, normal biological function is restored. The other thing we're going to look at are what are the functional categories of nutrients. And there's 3 categories. 1, those that primarily provide energy. 2, those are necessary for growth and development. And 3, those that are necessary to keep the body functioning smoothly. Think of that as necessary for the maintenance of homeostasis. Now, here we're looking at a general characterization of how we're going to describe nutrients within the human diet. The first is energy-yielding nutrients, and we have the big 3. So carbohydrate and glucose is probably the best example. So glucose we're going to consider as a building block in carbohydrate. Lipids, we're actually going to have some that are essential in nature, so primarily omega-6 and omega-3 fatty acids. And then proteins, and here we see the building blocks, an example of some of the necessary amino acids overall. Now, non-energy yielding nutrients are going to be vitamins, minerals, and water. Now, you see that there's a questionable category there, but I'm not going to put a lot of emphasis on those. So just keep in mind that what this table is telling us is distinguishing between energy yielding nutrients and those that are non-energy yielding. So that's an important distinction and characterization that we want to make as we study our nutrients. Now here are the functional categories. And so if we look at those that provide energy, that is the primary job associated with carbohydrates. Energy can be obtained from protein and also from lipids. If we look at those nutrients that are responsible for growth and development, proteins, lipids, some vitamins, some minerals, and water fall under this functional category. And those that regulate body processes, proteins, some lipids, some vitamins, some minerals, and water. And notice what you see in this particular slide, that they cross. So some of these nutrients are going to be involved in more than one category. So I want us to make sure that we're comfortable with that factor. Now, the other way to look at nutrients are macro versus micro. Macronutrients are those nutrients that we need to provide to our body in relatively large amounts. Unsurprisingly, this is where we see our energy yielding nutrients, so carbohydrates, lipids, and protein. But then we see the most necessary essential nutrient of all, and that's going to be water. Now, micronutrients are going to be those that are necessary or required in much smaller amounts. So vitamins and minerals are really good examples of micronutrients. So you should be able to distinguish between macronutrients versus micronutrients. Now, each one of these next energy yielding nutrients and also vitamins and minerals are going to have their own chapter associated with them. Now, when we look at carbohydrates, a couple of things we want to keep in mind here. Okay, they're primarily made up of carbon, hydrogen, and oxygen. We're going to kind of think of those as the big three. And they're going to be things that are primarily obtained from fruits, vegetables, grains, and beans. If we look at the two major subdivisions of carbohydrates, we have simple, and these are going to be monosaccharides. So blood glucose is a good example of a monosaccharide. And then we have disaccharides such as table sugar or sucrose. Then we have complex carbohydrates, and they're highly branching typically. And so really good examples of complex carbohydrates are going to be starch, glycogen, and fiber. As noted earlier, we're going to spend a lot more time talking about these in greater detail. Now, another factor that you have to remember is the energy that I get from 1 gram of carbohydrate, and that's going to be 4 kcals per gram. We'll talk about energy requirements a little bit later in another screencast for chapter 1. The other thing I want you to keep in mind here is carbohydrates are polar. So they are made up of polar covalent bonds. So that is a another very important characteristic we want to keep in mind about carbohydrates. Next, we have lipids. These are actually composed of the same things as carbohydrates. So carbon, oxygen, and hydrogen. But now we're looking at things that are nonpolar. So these are insoluble in water or hydrophobic. They also are what we will refer to as energy dense. So generally, we are going to get 9 kcals per gram of lipid. Now, there is a further physical distinction between our fats. Fats are going to be lipids that are solid at room temperature, and oils are characterized as those lipids that are liquid at room temperature. So a very important distinction between the two. Now, triglycerides are the major form of fat in our body and how we get the majority of fat in our diet. We use triglycerides, especially for energy in resting states. That's going to be important. And the triglyceride is actually made up of 3 fatty acids attached to a glycerol backbone. We'll spend a lot of time talking about that when we look at the actual chapter devoted to lipids. If we look at some other characteristics, we can basically describe them as saturated versus unsaturated. Saturated fats typically are those solid at room temperature. They primarily come from animal sources. The research indicates that they play a role in raising or increasing levels of cholesterol in our blood, and also that they play a role or can lead to cardiovascular disease. So quite often, I don't like using the term good or bad, but when it comes to saturated fats, they're bad. There's just not, I can't say anything else that's that. Now, unsaturated fats, this is mostly our oils and those things that are liquid at room temperature. Many of them are found from or originate from plant sources. Think about our oil. So olive oil, that's a really good example. And they are healthier than saturated fats. Now, essential fatty acids are those that you must get from your diet. And those are going to be linoleic acid and alpha-linolenic acid. So those are the two primarily. And they play some really critical roles within the body. They are important components of cell membranes. They play a role in the regulation of blood pressure, regulating nerve transmission, and generally the best source of these essential acids are going to be vegetable oils and fish, especially fatty fish, such as salmon, tuna, halibut. And when I use the term fatty fish, I'm not talking about Friday fish fry. Those fishes that on their own originating from cold water, and because of that have a relatively high fat content, and that is going to be a overall unsaturated fat. We'll talk about that once again when we get to the lipid chapter. Now, the other time that I'm going to use bad in terms of lipids is when we talk about trans fatty acids. Okay? There is no good in them whatsoever. Unsaturated fats that have been processed from a normal cis configuration to a trans. We'll go into more detail about that a little bit later. But what happens is basically you've heard of that term partial hydrogenation. And that is a process that actually changes the configuration around the double bond that's found in these unsaturated fats that have been processed. Generally, they're found primarily in deep fried foods, baked snacks. Basically, they were originally invented to increase shelf life of things such as cookies, Twinkies, and things like that. And they tend to be solid. Okay, that's going to be important. They definitely are not good for us and do pose a health risk, which is why I will use the term bad. And we should minimize the amount of trans fats along with saturated fat. Those two fall under that category of bad fat. Now, before we get much further, what I want us to kind of think about, let's not demonize fat. The only bad fats are those that I've talked about already, the saturated fat and also trans fats. Fat is required. It's a required essential nutrient. So it's one of those major energy yielding molecules that has been demonized. Whereas the only real bad ones are trans fat and saturated fat. Proteins, I don't like playing favorites, but these are probably the most important from a physiological standpoint. Now, what's going to separate proteins from other of the essential nutrients or energy yielding nutrients, in addition to carbon, oxygen, and hydrogen, they contain nitrogen. Now, the role that we will find a little bit later when we look at the protein chapter is very diverse function. Proteins play a major role in all processes that take place within the body and really are involved in homeostasis. And you really can't talk about physiology without the role of proteins. So that's going to be really important. Now, proteins are going to provide 4 calories per gram, so they have the same energy yield as a gram of carbohydrate. So that is something that they share in common. Now, when we look at the building block of proteins, it's going to be amino acids. One important characteristic of proteins is the relationship with structure and function. If I change the structure of that particular protein, we now call that protein denatured, and it's no longer going to have the functions it is designed to. Once again, we'll look at that in much greater detail when we do our protein chapter. Now, vitamins and minerals, and I'm not going to go into a lot of detail here because we're actually going to look at 4 chapters devoted to vitamins and minerals. Now, if we look at things that they share in common, okay, primarily with our, between all of these, we're going to be looking at the main function is to enable chemical reactions to occur. Now, notice what I just said. They help release energy, but do not provide energy. Now, if we look at vitamins, basically there are 13 of them, and they're broken down into 2 groups. Those that are fat soluble versus those are water soluble. The fat soluble of the 13 are 4, vitamins A, D, E, and K. These are those vitamins that we accumulate and potentially result in toxicity. So that's something we have to keep in mind. Then we have water-soluble vitamins. So this is going to be vitamin C, the B complex vitamins. Now, these are also susceptible to damage by cooking. So boiling something is a really good example that is going to destroy most water-soluble vitamins. The other thing is we really don't hang on to these. They are excreted from the body more readily, and that's generally through urine. Now, minerals. Now, the other thing, vitamins are organic. Okay. Now, minerals are kind of the opposite to that, and they are inorganic. They do not contain carbon atoms that are bound to hydrogen. They are not destroyed by cooking. They do share something with vitamins that they yield no energy. Now, if we look at the major groups of vitamins and minerals, we're going to have major minerals, and these are required in large amounts at the level of grams, so a lot. Whereas trace minerals are going to be needed in those amounts less than 100 milligrams per day. So remember, once again, essential, but not energy yielding. Now, as noted previously, the most important of all essential nutrients is going to be water. It's what we require in the most amount of quantity. So we need to have large amounts of water on a regular basis to maintain homeostasis. We can go days and long periods of time without food. That's not something that we can do with water. Okay? Now, if we look at role that water plays within the body, it's a solvent. Okay? It's actually going to act as a lubricant. So think of synovial fluid. Transport nutrients, so think about blood, and plays a very important role in helping to regulate body temperature. We'll talk a lot about that once again as we get to the chapter that's going to be devoted on water. Now, sources primarily food that we ingest and, of course, things that we drink. Now, water is also a byproduct of metabolism. So kind of remember when you talked about glucose oxidation. Water is actually a product of the oxidation of glucose when ATP is yielded. Now, the last category, okay, these are not essential. They're phytochemicals and zoochemicals. And look at table 1.3. I'm not going to go through all of them, but phytochemicals typically are things of plant origin, and they are physiologically active, and phytochemicals may provide some type of health benefit. So if we look at some examples, as far as you may have heard of flavonoids, so those are found in citrus fruit, onions, apples, grapes, red wine, tea, chocolate, tomatoes. If we look at lycopene, that's actually something that is available or found primarily in tomatoes. So These are things that we know have some health benefits, and phytochemicals come from a plant origin, and zoochemicals are physiologically active compounds found in foods associated with animal origin. So some examples of those are going to be conjugated linoleic acid, and those are found in meat and cheese. You should be able to generally categorize that phytochemicals come from plants and zoochemicals are from animal origin.